Hello everyone, I'm Yvonne, a children's librarian here at the Manchester City Library, and I want to welcome you to Elementary Experiments this winter. Here we are going to do experiments and activities aimed at elementary grades 1 through 6 with a focus on STEAM or science, technology, engineering, arts, or math. With school and winter breaks, we know that everyone has things to do, so we will continue to post 2 elementary experiments here online and then do them together on the last Tuesday of the month at 3:30 p.m. at the Manchester City Library. So if you want to join us in person, do please go to our website to register to make sure that we have enough supplies and crafts for everyone. So we are continuing to post here to share our crafts and activities with as many people as possible. But if you are in grades 1 through 6 and you like what you see, remember that we will be doing our monthly wrap up in person on the last Tuesday of each month. So now that we have gotten all of that covered, let's get into this week's elementary experiments. Hello everyone, and welcome to the first Tuesday of January. We are going to be learning a little bit about odd ice in this elementary experiment. That means we are going to be talking a little bit about the odd qualities that ice or frozen water has, and then we're also going to do a little bit of fun experimenting with crystallization. So I'm going to go right ahead and get into our first activity. All right, everyone, welcome to our odd ice activity where we're going to do a little bit of ice fishing. So I have collected everything I need. So I have my 4 glasses. I have some ice cubes, I have some water, some salt, I have 4 different strings of yarn or cuts of yarn, and then I have some sticky pads. Now they don't actually need to be sticky pads, you just need something that you can indicate which of your cups are going to have the added salt. Sticky notes are just easiest because I can just take it off and stick it on. So what we're going to do is we're going to put water in all 4 of our cups, and then we're going to add a couple of ice cubes to each of them. Then we are going to leave 2 of them just as they are without adding any salt at all. And then we are going to add salt to the 2 other ones, but we're going to do them in a slightly different order. Now I know that before with other activities we have talked a little bit about experiments and how you set up variables versus constants. So a variable is something that you change in an experiment, and a constant is something that you keep the same. So like we're going to put like the same amount of water, and it's all just plain tap water in each of the cups. All of my string, they're all from the same ball of yarn. So that is a constant. We're using ice, all from the same shape of ice tray. That's going to be a constant. And a variable is what we're changing. So in this case, our variable is whether or not we add ice. But with this experiment, we're also adding another vocabulary term, and that's going to be a control group. So a control group is something where you have a group or one sample, 1 cup in our case, where you don't do anything special to it. You leave it exactly the same as it would be like normally in nature, right? And so in that case, it is also going to be just water and ice, so that we can compare that, how it works with just water and ice and no salt versus a salt that we put the salt on before we put the string on, and then one sample where we put salt on our ice and then put the string. So those are another set of variables, and we use the controls so that we can compare how it would work without salt. All right, I hope that made sense. I'm gonna go ahead and put in the water and the ice before we get into the nitty gritty of the experiment. All right, now I'm going to mark the cups that I'm going to put salt into. So this one, I say that, this one here, and this one here. All right, so these two, this one we're gonna put the salt in and then add the string, and then this one we're going to put the string and then add salt where the salt is going to be. All right, so here we're gonna put that, lay it across the ice that's floating on the top. Then here we're going to put this also, lay it across the ice that's floating on the top that now has the salt on it. All right. And then we're going to lay our string over the ice. Whoop, I'm going to try. Our string over the ice, and then on this one we're going to put the salt on top. So now we have to wait a few minutes. Let's wait about 3 minutes, and then we're going to check, and we're going to see if we can pick up our strings, and if the ice will actually come up with the strings. If we can fish for the ice. Oops, my ice is trying to escape. Okay, I think that's on that ice pretty well. Okay, so we're going to let that do its thing, and then we will meet back here to test it. All right, we're going to go ahead and give this a try. So here we are. This is one of our controls. If we lift up the string, we're definitely not getting any ice with it. This one here is the one where we sprinkled salt and then put on our string. Whoop. All right, we're definitely getting a little bit of lift. There's definitely some sticking, but it's not going to lift up a whole ice cube. All right, here is one where we just used water. Nope. And this one here where we used put down the string and then sprinkled the ice. Oh yeah, look at that. All the way up. We definitely caught some ice with this one. All right, so we can tell, see, it had it and then it dropped it. So we can definitely tell that the addition of salt really does help us help the string stick to the ice, and that putting the string down first and then sprinkling the ice on second definitely help the string stick the best out of what we've tried. So why do you think that the salt helps us to fish for ice? So you may know that in wintertime, people might add salt to ice to get it to melt. If you've ever heard the expression that they're like salting the roads, so that is adding salt to the ice so that it melts and it's safer for cars to drive on it. Nowadays, they often don't use actual salt, although they did in the past, because adding a lot of salt to our water that like gets washed into the grass and stuff is not good for the environment. But it's still the same idea. So when you sprinkle the salt over the ice, it dissolves a thin layer of water over the top of the ice, just like it does when you add it to roads or sidewalks. And because salt water freezes at a lower temperature, so it has to be colder for salt water to freeze than it has to be for plain water to freeze. And adding the salt makes some of the ice melt, and that means it absorbs some heat in the process. And the energy that makes heat has to come from somewhere. So it actually can pull the heat from the surrounding area, lowering the temperature again. So the area around the salt will melt and then refreeze. And if the string is in the area that melts, then the string gets stuck into the newly liquefied water. And then when it refreezes, the string is already in that water. And so the string gets frozen into the ice. So without the salts, the water and the ice cube remain at the same temperature. And so the string never has the chance to get frozen into the block of ice. And so that's why both of our ones with string and salt actually did stick. And then why do you think that the one where we put the string first and then added salt did better than the one where we added salt first and then put the string? Think about what we've just learned about how ice and salt and the refreezing process happens, and I think that you can get some good ideas. All right. Well, I hope that you have enjoyed learning a little bit about how salt interacts with ice and kind of just the odd ways that ice behaves. Freezing water actually acts a little bit differently than how we freeze most other like molecules. And so it is really fascinating to learn more about that. And if you want to expand on our experiments and test out how adding other items besides salt might affect the freezing and refreezing of ice and your ability to fish for ice with string, then please have some fun with that. I just ask you to be careful and make sure you have a safe area to do that in, because remember, with our elementary experiments, we want to be, first of all, safe, second of all, have fun, and third, learn some interesting things. So I'm going to go ahead and clean up. As I mentioned, if you're not done experimenting, then please continue to have fun safely. But this is it for me, so I'm going to clean this up, and then I will meet you back here when you're done, so that we can go over a couple things. And I will, of course, share with you some fun books if you want to continue reading on this subject or slightly related ones. All right, so for our odd ice craft, we are going to be making some borax crystal snowflakes. Or really just borax crystal sculptures. You can do what you would like as far as what you are making. As usual, we will have our kits available in the at the children's reference desk. So we're going to have some kits available when this video goes out. So if you are nearby the Manchester City Library, you can drop in and pick one up if you are a kid in 1st through 6th grade, or if you want to send your parents to pick one up, just make sure that they let us know. And inside of it, we have our instructions as usual. We also have this cup, a little condiment container. This has about 3 tablespoons of borax powder. So a borax powder is like a laundry detergent, so I just want to make sure that nobody eats it. Of course, you should never eat any science experiment unless you are very specifically and carefully making something that is safe to eat. And this is not one of those things. So we want to make sure that we do not do that, and that we clean anything that we're going to use for eating later. Like from home, I brought the spoon that I'm going to use to stir, but I will wash that before I eat anything with it. But back to our kit, we also have a couple pipe cleaner options. So if you want to make a tree, some of our kits have an extra green pipe cleaner in them, and then a couple of white ones as well. So I'm going to go ahead and make a snowflake because our odd ice is still focused on water and freezing and the cool things that happen. So I'm going to go ahead and start creating that. A snowflake has 6 spikes on it. So I'm going to go ahead and make my center and then build my 6 spikes. I'll probably need my second one. I'm going to try and do this without cutting my pipe cleaner. We'll see how that goes. I will warn you that if you do use scissors to cut the pipe cleaner, make sure that they are not nice scissors, because the pipe cleaner does have metal in the middle. So any scissors that you use to cut the pipe cleaner do have to cut through the metal, and it can dull your scissors. So you definitely can use scissors to cut through, but I just want to make sure that you're not using like someone's fabric scissors or scissors that people need to be very sharp. All right, so I'm going to go ahead and try to sculpt a snowflake out of these, and then we will meet back for the actual crystallization step. All right, so here is my snowflake, and I do want to make sure that it still kind of fits in my cup, because what we are going to do is we are going to take our borax and we are going to pour it into our cup, and then we are going to take our approximately 1 cup of warm water. So you want to put the water in a heat-safe container and heat it up. I put mine in the microwave in the measuring cup, which is safe to put in the microwave. We're going to put those together, and we're going to stir them up, and we are going to make what is called a super saturated liquid. So basically, because our water is warm, it's actually able to absorb more of our borax than it normally would if it was at a cooler temperature. And then we are going to put in our sculpture. In my case, I made a snowflake. And when we put our snowflake into our super saturated mixture, it's going to give all of our borate particles something to crystallize onto. So it's going to disrupt all of the borate that is evenly spread throughout all of our water. And the borax is going to find these impurities, which is just our pipe cleaners. And the particles are going to latch onto those and start forming crystals around them. So if you want to turn this into a full-on science experiment, you can actually test to see if there are other things that will make crystals on pipe cleaners. So if you get like 3 different cups and you make your pipe cleaner sculptures as close to each other as you can, and then you super saturate different things in the warm water, like you have your borax, and then you could try maybe some other things that are crystals. So if you tried salt and you tried sugar and you mix as much salt that will dissolve in the cup of water and as much sugar in your second one, and then put in your pipe cleaner sculptures into each one, and then set it aside to form your crystals for a certain amount of time. You can compare how each one does. But that's all extra. I'm just going off because I love experiments. What we are going to do right here, right now, is to go ahead and pour our warm water into this cup here. Then I'm going to take my 3 tablespoons of borax powder that is in this little condiment cup. I'm going to pour it in, and I am going to stir until all of that borax powder has been dissolved into my water. Okay, so my water is still pretty cloudy, but that's okay because the actual particles of the borax have been dissolved into my liquid. All right, so then we have our pipe cleaner. And you know what? I haven't actually done this before, but I've been curious as to what would happen if I added a little bit of color onto this. So this is an extra step that I just want to do to see what will happen if I add some color onto my pipe cleaner. Okay, well, we're gonna see. So I'm gonna take my pipe cleaner and I am going to put it into my mixture, and I am going to set it aside in a place where I know it will not be like knocked into, because we want to leave it undisturbed for the best crystal formation. So if it gets hit or jostled while the crystals are being made, they might not be like as cool as they could be, although they should still form. So I'm going to go ahead and I'm going to drop my snowflake in, and then I'm going to put it aside somewhere I know it will be safe and will not be moved for at least a day, so at least 24 hours, maybe 2 days, so maybe 48 hours to get the crystals to all form. And so that is going to take some time, but I did go ahead and make one earlier so that I could show you guys one of the finished products, actually 2 of the finished products. So here I already dumped the liquid out of it, but here is a snowflake that I made earlier. I don't know if you guys can tell how cool and sparkly it is. It got some really good large crystals that grew on this one. And then you can see I have like extra crystals that formed in the bottom of my cup. I did actually have to kind of like knock the cup to get the snowflake to detach from the bottom. So if that happens to you, just be careful as you do it, but you might have to like kind of bang and yank on it a little bit. And then this is one I did earlier. In fact, this one I did last year. And this I made a tree from a green pipe cleaner that I put in a borax mix. And this just shows you how even if you use the same like solution, so even though I used borax, it did turn out quite a bit different, although still very pretty. As for the color that I added, I don't know how that's going to work. And so if you want to see the end results for that one, I think you're going to have to come to our in-person elementary experiments, which will be on the last Tuesday of this month. So we will see if that addition did anything. But that is all that I have for this craft. I hope that you enjoyed it and made some really cool crystal sculptures, or possibly crystal snowflakes. So I'm going to go ahead and clean up the little bit of mess that I made here, and then I will meet back for a few words before we say goodbye for this week. All right, so thank you all for joining us and learning a little bit about odd ice in this week's elementary experiments. I hope that you had some fun, and I hope that you remember that we will be doing both the activity and the craft, or at least having the things to start the craft at the last Tuesday of this month for our in-person elementary experiments. I'm actually also hoping that we'll be able to do a hot ice experiment in our in-person event. I'm still working on getting that to work right, so I can't promise it, but I'm really hoping that we'll be able to pour out some crystallizing hot ice in person. So maybe come for that if it works. But we will definitely have our other activities and crafts, both what we did in this video and then the video that we are going to put out on the third Tuesday of this month. We will also be doing those activities and crafts in our in-person event. So if you are in grades 1 through 6 and you're going to be in Manchester on the last Tuesday of this month, go ahead to our website and register, so we'll make sure we have supplies for you. Other than that, I am going to put up some book recommendations if you want to learn a little bit more about ice and water. So I'm going to have those up and the sneak peek on what we're going to be doing in the next video. So that's all I have. I hope to see you back here on the third Tuesday and possibly in person on the last Tuesday of this month. But until then, bye.